BOGO sort, also known as permutation sort, slow sort, or stupid sort, is arguably one of the worst, if not the worst sorting algorithm there is. Well, so why then start a series on sorting algorithms with this algorithm, you might ask? Well, there are three reasons. First, conceptually, it's super simple. Second, coding-wise, it's not that hard either. Third, we're just getting started here, people. I don't want to give away the best algorithm just like right at the start. So what is it that BOGO sort does, and why is it so slow? To see this, let's just pause the animation here for a moment. You can see that two of the bars here are highlighted. One is red and the other one is orange. BOGO sort has just swapped these two bars. Why these two? Well, BOGO sort had selected them at random. And in the next step of the sorting process, it will just select another two bars, completely at random. It does this at every single step of the animation. After each swap, BOGO sort then runs just like a quick check on whether the array is now sorted. Of course, BOGO sort needs to get really lucky here. A single lucky swap will just not be enough. No, from all possible sequences of swaps, BOGO sort has to find one that leads to the entire array being sorted. So if the array contains more than just like a couple of elements, this will be extremely unlikely, and BOGO sort will virtually run forever. Notice also that completely random swaps imply that after a very lucky sequence of swaps, which almost sorted the entire array, the next couple of random swaps might just undo all of that work. But anyway, as I said, the algorithm is super simple, and thus this is a good place for us to start nonetheless. So let's head over to our text editor and start coding. Okay, so I'm now in my text editor, and I'm going to define a new method, which we're going to call BOGO sort. So BOGO sort. And this method will just have a single argument, which will be this A. The single parameter is this will be the array that we're going to sort. Now, at first, we're going to assume that the array is not sorted, and then we start an iterative process of where we are swapping two elements and then checking whether that did the trick, whether the array is now sorted. So let's define this Boolean variable here called isSorted. And let's set this to false, because at first the algorithm will assume that the array is not sorted. And now we're going to start this while loop, this iterative thing. So while A is not sorted, while not is sorted, we'll now constantly be doing two things. First, we'll swap two elements. And then in the second step, we'll check if the array happens to be sorted by now. So how do we make the swap? Well, we're going to select a random index I and a random index j. Now, to randomly select an index, we first have to have the ability to do random things. And in Python, we can do that by importing the random module. So we'll type import random. And now we can use the random integer function, randint, to select a random element between 0, because Python uses zero-based indexing. The first element in an array has index 0, and then n-1. So the array has n many elements, and n-1, because of this zero-based indexing, is the last element in the array. Of course, we have not defined what n is yet, so we'll have to insert this up here, that n is the length of the array. Okay, so let's copy this down here. So now we have two elements here, and now we can swap them. AI and AJ are now going to be swapped, and we can do this in a single line of code here, just by having it read AI, AJ on the left of the equal sign, and then AJ, AI on the right-hand side. Okay, now we swap these two elements, and now we have to check whether the array is now sorted. How do we do that? Well, we're going to start by assuming that the array is now sorted. And now we're going to loop through the array. So for I in range 1 until n, what is it we are going to do? We are going to compare the ith element with its predecessor. Okay? And if I is smaller than the element preceding it, then the array is not sorted because we always want to have the very large elements to the right and the small elements to the left. So if an element is smaller than its predecessor, then the array is not sorted yet. Technically, we could make this a smaller or equal to sign, but here we are not going to assume that there is any array elements that are equal in size, okay? So just bear this in mind in case you're working on a different project here. You might have to use an equal or less than operator here instead of this just smaller operator. Okay, so if this is the case, we can set is sorted to false, because now we already know that the array is not sorted because we have found a single instance of where this condition does not hold. Well, this condition holds, this smaller than condition holds. So a single instance is obviously enough, and therefore we don't have to search further for any further instances of where this array is not sorted. So we can just break out of this loop here that constantly checks whether there's an instance of two array elements being out of order, and we can come back to the main loop, the while loop here. The array is not sorted. We just set is sorted back to false, and now we're going to go through this over and over again. Okay, so let's see whether that works. Now to check whether this works, we first have to have an unsorted array. So let's just define something. I'm just going to throw in a bunch of random numbers here. 5, 3, 4, 2, 1. And let's see whether we can BOGO sort this. So I'm going to print A. Then I'm going to use BOGO sort. And then I'm going to print it again. And yeah, now it's time to run this script. And okay, so I got an error here, and it says okay, this is obviously super false. While not is sorted, the A does not have to be included here. I guess most of you were like thinking this entire time, what is he doing there? Okay, while not is sorted. Okay, so let's run this again. It's still false because, geez, while not is sorted. I think that's all we need, right? Is sorted is just a Boolean variable. I'm going to negate this. I don't have to have any is because we are not like comparing it with none or anything. It's really just while not is sorted. Geez. Okay, you saw that this worked. At first we have 5, 3, 4, 2, 1. And now it reads 1, 2, 3, 4, 5. And the whole thing just took like 26 milliseconds. So it's pretty fast, but bear in mind, we just have like 5 elements here. And if this was just a little bit more, so let's just insert 6, 7, 8, and 9. Now it's taking some time. And now the script is running and it's 2.3 seconds. And you can really see how this is going to accelerate. So let's just add a 10 here and see how long that is going to take. I mean, of course, it's random. It's kind of hard to predict how much longer it's going to take, but before it took 2.3 seconds, and now on my machine it's taking 13.6 seconds, and this is very long. Notice also that we don't have a return statement in this function. This is because we are sorting in place, right? We have this array A here, and we're just altering it, and then in the end we're just printing it once more. So we are printing the original array, then we are sorting it without having a return statement anywhere in our code, and then we're just printing it once more, and well, here's the final result. Okay, this is all nice and well, but how are we going to visualize this? A very simple way of visualizing something in Python is matplotlib, because matplotlib, this library, has a function called pyplot, and pyplot is very great for making static images. Pyplot or matplotlib also has some animation capabilities, but they are not that great, at least not as great as using Pygame, I think. And for now, we are going to stick with matplotlib and the pyplot function, but later on we'll get into Pygame and we'll transition to Pygame because Pygame is a lot faster, it's a lot smoother, and the animations just look a lot better. So what you saw at the beginning of the video, that was done in Pygame. So for now, we are not going to be doing that, but we'll introduce it at some later point in the series, okay? But for now, matplotlib and the pyplot function. Let's import this. So from matplotlib, import pyplot. Okay, so let's go down here before we applied the function or anything. Let's just see if this works. PyPlot dot. Okay, so we have to say what type of plot we're making. And here we're going to have a bar plot. So I'm just going to type bar. And now we have to specify a bunch of x locations. And here we're just going to say take all values from 1 until the length of the array. So until length of a. I'm going to have to add +1 here because we are starting at 1. I mean, we could start at 0, but I think it's just easier to say the first element is in the first position on 1, 2, 3, and so on. And then we'll have to specify the height of the bars, and here we're just going to use our array. So the greater the element in the array, the taller the bar, obviously. And if we run this, nothing really happens, right? Why is that? Well, we have to tell PyPlot to actually show the plot. The plot has been created, but it's not there. Let's have a look here. So it's 700 milliseconds. And if I exclude this line, it's a little bit less, but it's still fairly slow. Maybe this is this import thing. I don't really know. Anyway, let's type pyplot.show. And there we are. Here is our array visualized using a bar chart. Let's just see whether this is correct. So the first bar is 5. So yeah, this works. This is 5. The second bar is supposed to be 3. Yeah, this works. Yeah, so we just visualized this. Okay, we don't really need the axes values here, so we can just turn this off by typing pyplot.axis and then off. So if we do this, the plot looks like that. And I think this is all that we are going to need for now. Later, of course, we'll redo this in Pygame. Anyway, let's get this animated. So the most easy way to do this would be to just insert this piece of code right after we did the swap. So just going to say visualize here. But before you run this is very important. Let's shrink the array size. Let's just make this 3 elements. You know what? I'm just going to make it 1, 2, 3 here. And let's run this. Okay, nothing's happening because I have not called the function bogosort. So let's do this. And boom, there's now a plot. You might now ask, well, why is there no animation? Why is it not moving? Well, Python or PyPlot is plotting a static image. And only if I close this figure here, another one is going to pop up. And then if I close this one, now the algorithm is swapping things and the bars are changing. And yeah, it's very painful to watch because it's super slow and I constantly have to close this window for the next one to pop up. And now the array is sorted. So if I close this one here, it's over. Why is it over? Well, because the algorithm has terminated. There is no more plot to show. So this is, I mean, it works, but it's not really a visualization or an animation because we want it to play automatically. So what can we do here? Well, we can move this bit down here, or let's delete this for the moment, but just say pyplot dot close figure. So it's going to make the plot and then instantaneously close it. So why would you do that, you might ask? If we just type pyplot dot pause and then just have it pause for like very small period of time, this should now run automatically. And there you are. Did you just see that? It's not working. So let's add in maybe one additional array element and let's have a look at this animation. And it's working beautifully. Unfortunately, once the algorithm terminates, the whole thing stops. But if we now add pyplot.show at the very end of the program, the window is not going to close. It's just going to stay on that final configuration of the array. So any second now, yeah, there it is. We now see 1, 2, 3, 4, the 4 bars aligned in ascending order, and this is exactly what we want. Okay, cool. So there's just another problem with this. And this problem, I mean, it's not a problem now, but it will be in the future. Now, every time that we are going to create a new script here with a different algorithm, we'll always have to insert this visualize chunk, this code block, right? This thing here, we'll always have to insert this. And this is kind of bad because, say, at some point in the future, we want to change something about this, say we want to change the colors of the bars or something like that, then we'll have to change this in every single file, in every single algorithm. So it would be good to kind of separate the algorithms, the sorting algorithms, from the visualization code. And only if we can keep these two things separate, we can make one little change to the visualization code, and then all of the algorithms will be visualized in this new way. So we kind of have to get this bit out of the equation, right? So we have to kind of move this down here. And notice also that it would be kind of cool to not have to type pyplot.show after the algorithm. Okay, so how do we do this? To fix this problem, we have to introduce a concept called a generator in Python. So in Python, you can run a function, or you can tell Python what this function is about. Of course, you're saying, well, I just coded this function. How does Python not know? Python does not know until it's compiling the script. So if we want Python to know about the function but not execute the function right away when the script is compiled, we have to use a generator. And a generator, you can think of this as storing a bit of information about how an algorithm works, but not running it already. But then later we can say, run this thing, run it once more, and so on. So we can, in a way, store every single frame of the animation in this generator object. And then later on, when we are actually trying to make the animation, we can access every single frame of the animation. Okay, so how do we make this a generator thing? The first thing we'll have to do is we'll have to use a command called yield. And here we're going to yield the array. So the yield statement is kind of similar to the return statement, but yield means don't finish the execution here. Return, if a return statement is reached within a method, within a function, the code will terminate. But if we use this yield statement here, now it's going to keep on running. It's just yielding more things, right? It's just yielding the array at every iteration of the sorting process. And now let's just see what happens. So let me just quickly make this a comment here, a multi-line comment. And let's just run this and see what happens. Okay, so it finishes fairly quickly, but we cannot really see anything. So what we are going to do now, we're going to call this the sorting process. And then we're going to print the sorting process. Okay, this is different. We can now see that it printed generator object called bogosort, and this is just the location in memory. So we have now successfully created a generator object. So you said, well, isn't this supposed to give us the different frames of the animation, the different arrays at each step of the sorting process? And you're perfectly right. So how do we access the individual arrays in their individual versions? Well, we do this using the next command. So if we print next sorting process, we can now see this little array here, 3, 2, 1, 4. And as you can see, we started with 3, 1, 2, 4, and now it's 3, 2, 1, 4. So the 1 and the 2 have been swapped as compared to their original position here, okay? So let's just type this a couple of times. And there we go. So now we can see the sorting process taking place one step at a time. So when Python compiles this script, it's not immediately executing bogosort in line 23. No, it's just understanding what it is that bogosort does. And now in line 24, it sort of executes one iteration of bogosort, and then in line 25, it executes the next iteration of bogosort. And this will be very useful because now with this ability, we can now loop through the entire sorting process. So I'm just going to say while true, print next sorting process. So let's see what happens here. We get an error, but if we look closely and if we scroll up a little here, let's make this a little larger. We can see that it actually printed out different versions of our array. And at the very end, it says 1, 2, 3, 4, and then comes an error. So what's the problem here? The problem is that all of a sudden Python says, I don't know what to do here anymore. the whole project has finished. Not the project, the algorithm has terminated. There is nothing to yield here. I almost said return, but it has to be yield. So there's nothing to yield here. So we have to tell Python in this next statement that if there is nothing to yield, just print none. So let's do this once more. And now it's just printing none, 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 none all over the place, right? So let's terminate this here. And instead of just constantly printing none, we could do something like this. We could say next step is equal to next sorting process with none. And now we can say if next step is none, well, if that is none, we're just going to break out of that while loop, else print next step. And now it prints 3, 4, 2, 1, 4, 3, 2, 1, 1, 2, 3, 4 at the very end. And this is now all we need, because now we can use this and reinsert it here. I can just have to take care of the indentation. Let's drop this bit here, have the pyplot.show at the very end. I just like having a line break here and there. And now A will be, okay, next step. I'm just going to call this next A, I think. Yeah, so next A. Okay, and yeah, let's run this. Okay, cool. So we have the same animation as before, but we have completely separated the algorithm part, so the BOGO sort function, from the visualization part down here. And now to really top this off, let's turn this into its own function. So let's have something like visualize. So I'm just going to call it visualize, and it's going to need a sorting algorithm. Okay, and what's it going to do? It is going to create an array. Then it's going to use the sorting algorithm to generate the sorting process. And then it's going to loop through the sorting process to visualize this. Okay, so let's just add in some comments. Create array. Generate sorting process. And down here it's going to say visualize sorting process. Okay, so if we run this, nothing happens, obviously. But now we can just type visualize BOGO sort. And if we run this, we now get the animation. How cool is that? So from now on, in every single video that's to come in the future, we can use this function visualize, and instead of BOGO sort, we'll just type whatever other algorithm we're going to visualize. How cool is that? Okay, let's just quickly recap. Okay, no, one more thing. It would be kind of nice to have the option to like have not only this array all the time, 3, 1, 2, 4. Of course, if we're going to look at better algorithms, we would like to have larger arrays in here. So instead of having this fixed array here, let's create a random array. So we'll just say random.sample. And now we'll have to specify what it is that we're sampling from. So we are now going to sample from a range of numbers that range from 1 to n plus 1. This will ensure that we have n many values in this array. And we're going to sample n many elements from this without replacement, which will then mean that this array A will include all integer values from 1 up to n. Okay, and yeah, I think that's all we're going to need here. So down here, we can now visualize BOGO sort with 3 elements. Okay, now it's 3 bars. This worked just fine. So let's run this with 5. This might take a while, but you can see it's now 5 bars. This is exactly what we needed. And yeah, this is looking really, really good.
In the future, we can add colors to this. This might be something we'll do in the next video, because this video, we already did a lot, right? Let's recap. We implemented our first sorting algorithm, BOGO-sort. We then added some code to visualize this using PyPlot from the matplotlib library. We then said, okay, intertwining or mixing the visualization code with the sorting code might not be a very good idea for the future. So we then learned about this generator object, this new concept that allowed us to separate the sorting code from the visualizing code. And now we separated these two things. We created a visualize function. And yeah, now in the future, we'll be able to just replace this BOGO-sort here with another algorithm. And we can just visualize that as well. And we even added the ability to control the number of elements that we would like to have this array to feature before we are going to sort it. Okay, colors, we'll add that in the future. Pygame animation comes in the future as well. But this is enough for the first video. Thank you very much for watching. See you in the next one.